Hi Anod, welcome to August IoT Studio. In continuation of our series, today we will learn about diode. So what is a diode? A diode is a semiconductor device that essentially acts as a one-way switch for current. It allows current to flow easily in one direction, but severely restrict current from flowing in the opposite direction. So first talk about the PN junction diode, then we will see the different type of diodes. PN junction diode consists of two layers of semiconductors. One layer is stored with P-type material and the other layer with N-type material. The combination of these both P and N-type layers from a junction known as the PN junction, hence the name PN junction diode. It allows the flow of current in the forward direction and blocks it in reverse direction. They are also known as rectifier diode used for rectification. There are different types of diodes that use the PN junction with variation in doping concentration. They are discussed below. Small signal diode. It is a type of PN junction diode which operates on low voltage signals. Its junction area is very small, due to which the junction has less capacitance and low charge storing capacity. It enables the small signal diode to have high switching speed with very fast recovery time. However, its limitations are low voltage and current parameters. Due to its high switching speed, these types of diodes are used in circuits with high frequencies. Rectifier diode. A rectifier diode is a type of PN junction diode whose PN junction area is very large. This results in high capacitance in reverse direction. It has low switching speed. This is the most common and most used type of a diode. This type of diodes can handle heavy current and are used in converting AC into DC. Schottky diode, a type of diode which consists of a small junction between an N-type semiconductor and a metal. It has no PN junction. The plus point of Schottky diode is that it has very low forward voltage drop and fast switching. As there is no capacitive junction, the Schottky diode switching speed is very fast. The limitation of Schottky diode is that it has low reverse breakdown voltage and high reverse leakage current. Super barrier diodes. Super barrier diodes are also rectifier diodes, but they have a low forward voltage drop. Just like a Schottky diode, they have a low reverse leakage current, just like a normal PN junction diode. SBR uses MOSFET contact between its gate and source. SBR has a low forward voltage drop, less reverse leakage current, and fast switching capability. Light emitting diode LED. The light emitting diode is also a type of PN junction diode that emits light in the forward bias configuration. LED is made up of a direct band semiconductor. When the charge carriers cross the barrier and recombine with the electron hole on the other side, they emit photon particles, while the color of the light depends on the energy gap of the semiconductor. LED converts electrical energy into light energy. Photodiode. The photodiode is a type of PN junction diode that converts the light energy into electrical current. Its operation is opposite to that of an LED. Every semiconductor diode is affected by optical charge carriers. They are packaged in a light blocking material. When the light strikes the p-n junction, it creates an electron-hole pair. This electron and hole flow out as the electrical current. To increase its efficiency, a PIN junction diode is used. A photodiode is used in reverse bias and they can be used in solar cells. Laser diode. A laser diode is similar to a LED because it converts electrical energy into light energy. But unlike LED, laser diode produces coherent light. The laser diode consists of a pin junction where electron and holes combine together in intrinsic region. When they combine, it generates a laser beam. Laser diodes are used in optical communication, laser pointer, CA drive, and laser printer etc. Tunnel diode. A tunnel is a heavily doped PN junction diode. Due to heavy doping concentration, the junction barrier becomes very thin. This allows the electron to easily escape through the barrier. This phenomenon is known as tunneling effect. The tunnel diode has a region in its VI curve where the current decreases as the voltage increases. This region is known as the negative resistance region. The tunnel diode operates in this region in different applications, such as an oscillator and a microwave amplifier. The tunnel diode also conducts current in reverse direction and it is a fast switching device. Zener diode. It is a type of diode which not only allows the flow of current in the forward direction but also in reverse direction. When the reverse voltage reaches the breakdown voltage known as Zener voltage, it allows the current flow. In forward bias, it operates as a simple PN junction diode. In reverse bias, it blocks until the reverse voltage reaches breakdown. After that, it allows the current flow with a constant voltage drop. Backward diode. The backward diode or the back diode is a PN junction diode whose operation is similar to that of tunnel diode and Zener diode, but the operating voltages are much lower. Backward diode is essentially a tunnel diode whose one side of the junction has a relatively less doping concentration compared to the other side. In the forward bias, it operates as a tunnel diode, but its tunneling effect is much reduced as compared to the tunnel diode. Otherwise, it operates as a normal PN junction diode. In reverse bias, it operates as a Zener diode, but the breakdown voltages are much lower. It is not widely used, but it can be used for rectification of a small voltage signal. Due to its fast switching speed, it can be used as a switch in RF mixer and multiplier. Avalanche diode. The avalanche diode is a PN junction diode that is specifically designed to operate in the avalanche breakdown region. Avalanche breakdown is a phenomenon where sufficient reverse voltage is applied to the PN junction, due to which the magnetic carrier ionizes and starts a heavy current flow in reverse direction. The heavy doping inside the Zener diode creates a small junction and low voltages can easily break it. However, the avalanche diode has a wide junction because of light doping concentration. Thus, it requires a high voltage for its breakdown. This wide junction makes it a better surge protector compared to a simple Zener diode. Apart from this, there are other diodes like transient voltage suppressor, gold doped diode, constant current diode, step recovery diode, vacuum diode, varactor diode, and PIN diode.
If you have any queries, you can ask in the comment section. I am providing you a link for the document related to this video. Stay tuned for my next video. Thanks and notes. See you later.